In this video, we're going to learn some very important things about how Java has chosen to implement object-oriented programming. We're going to be exploring the object class itself. To get us started, I've written a really basic program. It utilizes a custom class called myClass and creates two instances of this class, Object1 and Object2. We then call a void my method on each of these objects, which simply prints out the value that we've given them to contain. Then the program compares these objects. We first compare with this comparison operator that checks to see if these are actually the same object. We know that this will not be true because we can see that the objects were instantiated completely independently of each other. They share a class, but they're two different instances of the myClass class. We then compare these objects using the .equals method, which we'll be talking about a lot in this video. When we run this program, we see that the objects are found not to be the same, which is what we would expect. We also see that the objects are found not to be equal, even though the objects were both created under the same parameters and had the exact same things done to them from their creation to this point in time. So, what does it mean when objects are found not to be equal by the .equals method? The first question we should ask ourselves is, where does this .equals method come from, or where is it implemented? If we go to the myClass class, we don't actually find a .equals method, which is pretty weird because myClass is not declared to be inheriting from any superclass, but .equals is called directly on a myClass instance. In reality, myClass, as with all Java classes, does inherit from a superclass. At the very top of every class inheritance tree, even though it's not explicitly declared in our code, is the object class. If we head to the Java docs and look up the object class, we find this page and this definition. Class object is the root of the class hierarchy. Every class has object as a superclass. All objects, even arrays, implement the methods of this class. And then if we scroll down, we get this short but very important list of methods. Because all Java objects inherit from the object class, we can safely assume that any Java object we're dealing with implements each of the methods here. Among these methods is the equals method that we were just talking about and trying to figure out where it came from. This makes it very clear to us that our myClass is inheriting the .equals method from its object superclass. The definition of the equals method on the object level is very vague. It says indicates whether some other object is equal to this one. This vagueness to some degree leaves it up to us as programmers to determine on a class-by-class basis what equality really means. Let's say we come to the decision, the reasonable decision, that Object1 and Object2 should be determined equal to each other if the values they contain are identical. If we make this decision, then our current implementation of our program is not quite correct, because it's currently telling us that here Object1 and Object2 are not the same. In order to change this, we're going to need to override the equals method in myClass. Overriding an object class method is no more difficult than overriding the method for any other superclass. We simply declare an identical method, and this more specific method will be used when appropriate, when we're dealing with a myClass object. It's important for us to notice that the equals method does not take a myClass object as input. It takes any object as input. So before we can go ahead and compare this object's value with the value of our current myClass object, we need to protect ourselves and make sure that the object given as input is actually a myClass object. To do this, let's check some bad cases in which we would simply go ahead and return false without even comparing the inner values of these objects. If we've been given an object that hasn't actually been instantiated, or a pointer or a null pointer, we simply want to return false because our instantiated myClass object is not equivalent to nothing at all. More difficult question is this object we've been given an instance of myClass? Let's check the opposite of that. Let's check to see if object is not an instance of myClass. The instance of keyword lets us see what classes an object has within its repertoire. And if this statement does not evaluate to true, we simply want to return false because we'd be comparing a myClass object with a class that is not a myClass object. Once we've made it through these hoops successfully, it's safe for us to assume that we can cast this object to a myClass object. And now we can simply compare the value fields they contain and return that value. For this implementation to work, we will have to make value public. And then let's save this and jump back into our main method. When we run this method, we now see that object 1 and object 2 are found to be equal to each other. The object class declares a number of methods. In addition to equals, some important methods are hashcode and toString. We're not going to implement hashcode in this video because it requires us to do a little more math than is really wieldy. But I would very much recommend you check out how hashcode works by going to the documentation and exploring it. For now, let's just know that an object's hashcode method should return an integer value that describes this object. In all instances, if two objects are found to be equal through the equals method, their hashcode functions should also return the same integer value. If two objects are not equals as far as the equals method is concerned, their hashcode functions should return different values. At this point in time, we should be familiar with the toString method. This is also a method in the object class, meaning that we can call toString on any single object. But in our custom objects, until we've overridden toString, it's probably not going to return meaningful human-readable information. As you learn Java, I highly recommend implementing equals and toString even on the small little test classes you write while learning. It's a great habit to get into and keeps you thinking about object-oriented programming in the same way that Java does. When we create finalized software projects where we have public classes that other programmers may someday be using, we should be very careful that all of our classes properly implement these methods in an understandable manner, because Java programmers will expect to be able to utilize these methods to manipulate and understand our classes. Thanks for watching.